In week 6, we have several types of calculations that we need to discuss. All of these are calculations for weak acids and weak bases. Okay, so just remember that the calculations for weak acids are different from those for strong acids. For a strong acid, we just take the negative log and we're done. For a weak acid, we have to use an ice table because these are reactant favored scenarios. So calculating pH for a weak acid involves an ice table. So here's a sample problem involving a weak acid. Okay, so I say to you, what's the pH of a 5 molar nitrous acid solution? So HNO2. So yes, nitrous acid is a weak acid. Nitric acid is a strong acid. But because this is a weak acid, we're going to have to use an ice table. So we look up the Ka value. There's the Ka. And now we're going to write our dissociation equation. This is the reaction of an acid reacting with water. This is the generic reaction for an acid reacting with water is represented here. All we're doing is substituting our anion. We leave water out of our Ka expression, right, because it's a liquid. So its concentration doesn't change. So there's our Ka expression. And now we're going to set up our ice table. The initial concentration is 5 molar because we were told that in the problem. The initial concentration of these two is 0. We don't know anything about them from the problem. We're assuming they're 0 because we're just starting with a 5 molar concentration. Now that we know a lot about ice tables, we will know that the concentration of nitrous acid is going to go down by some quantity, and the concentration of hydronium ion and the nitrite ion are going to go up by some quantity. Okay, so now all we need to do is solve for X. We're going to make the 5% approximation because K is much, much less than 1 here. This is reactant favored, right? We're not going to assume that this concentration is going to change very much. So we're just going to plug in 5 here, X, and then X. Now we plug these into our Ka expression. Okay, so there's Ka is equal to H3O plus times NO2 minus over HNO2. So this is X, so that becomes X squared. This is 5, because we're using the 5% approximation. And then this Ka we were given in the problem. So now we just do some rearranging, multiply both sides by 5, take the square root. There's my value of X. We're going to plug that back into our ice table. 5, 4.74 times 10 to the negative 2, 4.74 times 10 to the negative 2. Now, the problem asks, what is the pH? pH is just negative log of H3O plus. We just solved for the H3O plus concentration, so all we need to do is now take the negative log. So negative log of H3O plus comes out to be 1.32. And so that is my pH of this solution. We had to do it the long way involving an ice table because weak acids are reactant favored, whereas strong acids we can just take the negative log and be done. For a weak acid, we do need to have a little bit more of an involved calculation. But it's not too bad, and if you follow these steps, you'll always do it correctly.